Hello, nag-start naman good. Sige guys, atin yung dali on, okay? Oh my gosh, I'll be using here as in my language of instruction will be Bishlish, Bisaya plus English. Somewhere along the way, I'm gonna combine two languages, Bisaya and English. Okay? For the record, I can also speak Taiwanese because I've been working in Republic of China 3 years from 2004 to 2007 in one of the electronics industry there. But it's not fluent. It's only a little bit, okay? And I can also speak a little bit of, not to talk straight, but I can understand a little bit of Hindi, like that. But I am poor in Arabic. I cannot speak, I cannot understand most of the language of Arabic. Okay? Like that. Because I worked before in construction, so the people there could either be Hindi like that or whatever. So I can understand a little bit of Hindi language. Okay? So muna siya. So English, Bisaya, Tagalog, Chinese, and a little bit of Hindi. Oh my gosh. Nakakaloka. Okay, going back. Okay, we have a compound composed of 52.14% carbon. So if you can see problems like this, so your brain cells would push you to think this particular topic. Okay? So I have, or the topic related to mass percent. Okay, mass percent of solute divided by mass of the solution times 100. So mass percent or percentage by mass. Okay? Get the point? Come on. Okay, solution, mga palangga. Okay? So we have 52.4% carbon, 52.14%. Okay. So, di ba mulit surat tayo when I was in college, I could remember, the instructor will just automatically say, if you have 52.14%, it will become automatically as 52.14 grams. Right? And then the student will think, where that comes from? During his discussion and your discussion, he will say 52.14% carbon, then it will become 52.14 grams, like that only, never stating where it came from. Okay, I will teach you. This came from the mass percent or percentage by mass, because I know some instructors will just shortcut and put immediately 52.14 grams like this, and they don't know, example, 13.13 hydrogen tradition, you will see also 13.13 grams, and then there's a magic from percentage going to the grams, and then and the students will follow like that, and then too much good in explanations, very intelligent like that, and the students will wonder why, where can she got that grams automatically. Okay, so it came from percentage by mass. I will explain a little bit. Okay, percentage by mass. Let's say this is carbon. You will say percentage by mass of carbon. Ganon. So mass of carbon is equals to the mass of solution times 100. Let's prove this why it becomes 52.14 grams. Because this is not magic. When it become the percent, it will become grams. So what the reason behind something like that? Okay, because the teacher is very fast, you know, like that, and then the students will, oh my god, we just found this. I'm experiencing that before also, that I need to share. Okay, like that. So nag-struggle ko for not all, because there's also some instructors who are very good and very articulate in their discussion. Okay, but mostly talaga siya. Okay. Basta engineering school, grabe kayo mga kuan. Sige, so, okay. So, now, if we have like this, okay, you need to compute for the mass of the carbon, which is 52.14. Okay? So, para makuha na itong 52.14, so you will solve for the MC. Right? So, MC, mass of the carbon, is equals to the percentage of the carbon given in the problem. Right? Which is 52.14, right? Times the mass of solution. Now, you don't have the mass of solution mentioned in the problem. Since this topic requires you to have a basis of calculation by theory and concept in general chemistry lecture, particularly this topic, volume percent also, and mass percent also, you have to have 100 grams of solution as your basis of calculation, especially if the problem doesn't mention the grams. If mentioned, the solution, you no need to assume the basis of calculation. But we are just very lucky, but most of the times in this topic, they don't have the grams in the problem. So let's have 100 grams of solution. Kung volume po siya, 100 ml solution like ito kay chuba-chucho. Okay? Like that. Now, 100 grams, our basis of solution. So you will say, 52% times 100. This will become 52.14. That's why 52.14 grams ang sa carbon. You get the point? So i-ditso na lang sa mga instructors because this is the way it should be. Okay? Erase. So the same thing, hydrogen, oxygen, we will do it that way, but let's also do the automatic because we understand already where it came from. Okay? Like that. So, we go now to hydrogen. Hydrogen is 13.13%, so it is also 13.13 grams. So, never do the calculation because it will be just the same because your basis of calculation is 100. It's exact. You need to compute again. Okay? And 34.73% of oxygen. So, oxygen, mga palangga, is 34.73%. By percentage, by mass calculation, we can obtain 34.73 grams also. Okay? The percentage of each element will always be equal to the gram in each figure. Like that. If our basis is 100 grams, and then if there's no mention in grams in our problem, because it will vary if there's a solution mentioned in our problem. For example, 10,000 grams, it's mentioned here, like this. Okay? We'll say, 10,000 grams of mixture composed of 52.14% carbon. So it will vary. You will never use no any more than 100 grams, even though if it is in the theory. You get the point? Priority, what is reflected in the problem. Secondary, standards, we have standards, tables, graphs, like that, constants. But if it's given in the problem, then use first what's reflected in the problem. Okay? You get the point? Muna siya. Okay? Okay. Now, the second step, guys, is to obtain the number of moles. Okay? Because we will get the atom by multiplying the moles and the subscript. Okay? Like that. Okay. So, muna siya. So, if you have 52.14 grams of carbon, now, get the individual atomic weight or atomic mass. Actually, it has the same meaning, guys. Atomic weight and atomic mass. But for me, it's also good to use the mass because we are not considering here the gravitational pull on the Earth's surface, which is using the acceleration due to gravity constants, right? The 9.81 meter per second squared, the 32.2 feet per second squared. Okay, because that will be a great factor when you compute for the weight. Okay, weight is equals to the mass over the acceleration due to gravity, right? And then since these are elements, okay, the gravity is not an issue. That's why we will just say atomic weight because the weight will be just equal to the mass. Okay, let's agree. But the more appropriate term is a mass. So that dili na siya malubog. Okay, we don't consider now the gravity. So atomic mass, molecular mass is the more correct appropriate term rather than using atomic weight and molecular weight, supposedly. Okay? I'm just discussing that for deeper technicalities. I also use the word weight for the purpose only of better understanding. That's why this is gonna be like that. So atomic weight and atomic mass is just the same. Molecular weight and molecular mass is just the same. Okay, because of the reason that these elements, the gravity is not an issue in computation of the weight, in which weight is equals to the mass divided by the acceleration due to gravity. Okay, the two constants in physics that we all always memorize since day one of the subject called physics. Okay, like that. Okay, going back to the solution proper, mga palangga. So if we see like that in the problem, automatically by judging, our brain cells will push us to think to the molecular mass or molecular weight again. So we will multiply this to the molecular weight or molecular mass, but take note, we need to flip this out so that the grams will be cancelled, or else it will never be cancelled. You cannot obtain the mole. So for example, if I have 12-gram atom of carbon, again, dito naman kayo sa technicality. So I'll say gram atom because carbon is only one. That is atom. If so many, you will say moles, gram mole. Sometimes the chemistry have also grammar. Since chemistry grammar is no longer an issue because we are focusing on the numbers, right? Numbers, and we get the answer correctly. That's it. But it's also good to know, the mechanism or the theory behind, or the applicability of the terms, and we must be also particular because it will help a lot in facing examination in the future. Because it will not end only in the classroom instruction. We will use this after you graduate in the outside world. You will be dealing with other professionals as well, especially if you are designing a machine, designing our equipment, designing different processes, chemical and physical processes, and you are hired as a process engineer or whatever in that particular reputable business. Then you know how to manipulate as per the theory concerns, right? So this is most matters a lot. Okay, so we need to flip that out. So the carbon will become 12 gram, 1 atom. And the gram will be cancelled, right? Like that. So it will become 52.14 divided by 12. So guys, I advise you need to differentiate first before going further. If you take BS chemistry and BS chemical engineering, take note first what is the difference between an atom and a mole, a molecule, a particle, an ion before proceeding. So that you have a clear understanding what's the difference and everything will follow. Right? The formula, the constants, the concepts, the laws, the principles, the derivation of the different formulas to have another formula out of those various formula, and then you correlate that one, you link that one, and you will derive another formula out of those different formulas, something like that. I-back up mo siya theories, okay? Like that. Okay, so as early as now, know the difference between atom, molecule, mole, ion, like that, charge, okay, valence, oxidation state, oxidation number, molecular weight, atomic mass, mass number, proton, neutrons, protons, electrons, positron, photon, okay, like the mesons, baryons, and sub-elementary particles also you have to know that, okay? Deeper elementary particles, sub-elementary particles, there are more smaller than protons. After that, there's smaller sub-protons, and you have to take a look at that. But anyhow, if your course is not really that nuclear engineering or chemical engineering or BS chemistry, you don't have to go deeper. It's enough, the neutrons, electrons, and protons for the purpose only for this type of courses. Again, chemical engineering, nuclear engineering, BS chemistry, metallurgical engineering, mining engineering, because a lot of chemistry will be there, okay, like that. And then petroleum engineering, okay, polymer engineering, and forensic science engineering. Forensic meaning more on the criminal investigation to analyze the samples, urine, blood, kung kasi nagpatay. So chemistry is very important, okay, to determine the percentage composition of different proteins found in your blood, found in your urine, then you have to know the chemical formula. What is the chemical formula of hemoglobin? What is the formula of red blood cells, white blood cells? Each has its own chemical formula, and you have to know that. What are the formula of RNA, DNA? So there's equivalent chemical formula for that. If you don't know the chemistry on that, then nga. Okay? So that's it. Okay, going back. So this is also very helpful also to that. Because this topic also can be applied to, for example, a compound of bilirubin, like that, found in your liver, composed of 52.13% carbon, ganon. Then you need to know the chemical formula of bilirubin in the first place. Okay? Which is the very dangerous compound that is present in your kidney, and then your kidney will be damaged. Okay, if more than 0.02, okay, milligrams per deciliter of the composition. Okay, things like that. Okay, so 0.14 gram divided by 12, pila mga palangga? Okay, ganun siya. So, I have here mga palangga, 52.14, nakakaloka, okay, 52.14, nakakaloka, divided by 12, nakakaloka. So 4.34 mga palangga. So 4.34 atom. Okay? Now, matala ko lang guys, kung sa'yo ako atom or mole? Oh, later na lang. Charot! So 13.13 divided by 1.008. The atomic mass of hydrogen is 1.008. Okay? So it's gonna be 13 mga palangga, no? 13.02. Okay. Yan naman siya. Grams per grams naman. Diba? Okay. Now, okay, 30 divided by 1.008 mga palangga. Okay. Oh, puri ka. I-round off lang na ito para sure. Charot. Okay. Now, on 34.73, what is the atomic mass of oxygen? Atomic mass of oxygen is 16 gram per atom. So 34.73 divided by 16 is equal to 2.17. 2.17 atom. Now add all the atom, it will become a mole. That's why it's called gram per mole na siya. If they are bonded together na in a compound. Okay? So this will become 4.34 plus 13.02 plus 2.17 is equals to 19.53 mole na siya. Okay, mole. Now, I will explain in this way why I'll say that mole is greater than atom. Because if you remember the Avogadro number, you know Avogadro number? 6.023 times 10 to the 23. That is 1 mole is equal to 6.023 times 10 to the 23. Imagine how high is that. Okay? So that's why I said if you add the different atoms, it will become the mole. Something like that. Okay? So it's gonna be 19.53. Now we have 4.34, 13, 2.17. Which is the smallest atom? Carbon, hydrogen, or oxygen? So it's gonna be definitely oxygen, 2.17. So divide each atom with 2.17. So I will write here C. So 4.34 divided by 2.17. Ganon. Okay, 4.34 divided by 2.17 mga palangga is equals to 2. Wow, perfect. So C2. Now, for hydrogen, 13.026 divided by 2.17. Ganon. So, I have here mga palangga, 13.026 divided by 2.17 mga palangga. So 6 It's here 6.003, so it's understood to be 6 only. So that is H6. Okay, the last 2.17 is the option. Of course, 2.17 divided by 2.17 is equal to 1. So you have to put only O. Or you can put 1, but 1 and nothing is just the same in chemistry. Like this. You can put 1 or you cannot put 1. It's just the same. Understood to be 1. So our empirical formula is C2H60. Oxygen, sorry. But this is not yet the molecular formula. Okay, this is still the empirical formula. Okay, so how can we compute for the molecular formula? The molecular formula, as I told earlier, that is basing on the chemical formula. So you should know the molar mass or the molecular mass, which is mentioned in the problem. Okay, 138.249 grams. Okay, let's compute that way. Let's compute now. Erase. Because I have a limited space in my whiteboard. I have to erase something. Yeah. You get the point? Okay, going back here, I have 138.204 as our molecular, okay, molecular mass. Okay? So 138.204 gram per mole is our molecular mass. Okay? Also known as molecular weight, also known as molar mass. So don't be confused. These three terms are used interchangeably in different problems that you will be facing in your classroom instruction, in classroom discussion, especially in chemistry and for facing examinations, whatever in the future. So molecular weight is just equal to molecular mass, is just equal to molar mass. You get the point? In here, molecular mass is stated, but maybe in other problems, they will say also molar mass, molecular weight, like this. Okay, it's up to you to try to remember that one. Okay, so this is molecular mass, and this is the basic on the chemical formula. Okay, basic on the chemical formula. Guys, as you can see in the problem, you don't know yet the compound really is. So, what branch in chemistry that deals with the study of determining what compound, what element is present in your mixture, solution, or in your colloid suspension, or in your homogeneous mixture, heterogeneous mixture? What study in chemistry all about? There's a lot of branches of chemistry. I already discussed that in my last month vlog, if you could still remember. So this is really, guys, qualitative chemistry. Qualitative chemistry. You should know what is that element present, what is that compound present, or what macromolecules are that present. Macromolecules, again, carbohydrates, nucleic acids, amino acids, protein, sugars, like that. So these are all macromolecules. Okay? You get the point? So that we can determine what's present, what's the name, then we need to solve in this way. Especially if the compound is unknown in your laboratory. For example, if your instructor is obtaining a sample of protein in a mouse or a cat, they kill the cat and the mouse and they get the protein sample in the laboratory and put in the test tube. Okay, and I have my students. He gives this sample to the students and then let them identify what is the protein present in that mouse. Okay, so in order to compute what the kind of protein, they need to determine the molecular weight, molar mass, and the molecular mass, because that is an identification. If we know the molar mass and the molecular weight, then we know the compound, we know the element, and we try to look to the periodic table which is closer, and then that would be our element, our compound, like that, blah blah blah, so and so. Get the point? Because some problems also like this, a compound composed of, but in this problem you are not asked for the chemical, for the name. We are only asked to the chemical formula. You get the point? Now, if in cases that the problem will ask you what is the name of that compound, I will add another question in letter B, right? Letter B. What is the compound? Because I know already the chemical formula. Then, the chemical formula is the basis of the name of the compound. Then, we can add a question like that also, in which is true in different examinations in the future. The problem will say, an unknown compound composed of blah, 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 so and so, like this, like this. What is the amount present? Okay? Or what is the element present? What is this compound? What is this metal? So you need to know through your computation by having the molecular weight, molar mass, atomic weight, atomic mass, like that. In here, we are very lucky because it stops only to asking for the chemical formula, not asking what is the name of that compound. Okay? Like that. Okay, going back. So we have the chemical formula. We need to find out because we don't know yet. Right? We don't know yet the chemical formula of this unknown compound. You get the point? And now we have the molecular mass and molecular weight which is present. Actually, I can go directly to the books. What molecular weight is will fit to this. And I can say, that is sucrose, that is citric acid, that is creatinine, that is uric acid, or there are a lot of chemical compounds inside our body. Okay, like that. Okay. So, like that, you have to determine. But since we don't do that because we will be dependent on the book, we will be dependent on the reference materials, we will be dependent what is being fed to us. Okay, sometimes we need to be independent without those books, without those social media, without those internet sources. Because that is an identification if you really know. Because not all the time we have books, we have reference. What if the question will be on the spot? And someone will ask you, what is the formula of, acetic acid? And you're a chemical engineer, and you don't know. So it's sagpa kailan mo sa chemical engineer. You don't know the exact formula or chemical formula of an acetic acid. And long years of passing by when we graduate is not an excuse. That was 10 years ago. You should know because you are a graduate of chemical engineering, you are a graduate of BS chemistry. You should know that it's not an excuse that you say, it was past 20 years ago and I don't know the chemical formula of manganic acid, permanganic acid, calcium carbonate, sodium carbonate. So it's a minus to you, right? Especially when you are a legit licensed chemical engineer. If you cannot know the chemical formula, it's a sagpa to you. So you should know that in the first place. Okay, going back. So if you have the chemical formula, then we can identify what is the name of that compound, of course. Okay, let's go back to the discussion. So if we have the molecular mass of 138.204 grams per mole mga palangga, the next step, what we will do for this? So we have the step 3. You have now to correlate the molecular formula and the chemical formula. How can you do that? So like this. So we need to have a ratio because you are referring to the same compound that you need to know. That's why we use ratio and proportion. Math still be used in chemistry. Okay? So ratio and proportion. You will say the molecular formula or chemical formula like that. Okay? Chemical formula like that. Okay? Will yield the molar mass of 138.204. This is ratio and proportion. Math. Okay. Now, the empirical formula. Actually, there is a direct also, but some of the instructors and teachers will not teach you this. They will go directly also to molecular formula. Why, sir? Why it become like this? Because it is a ratio and proportion that we need to account the relationship between the two because they have the same characteristic and behavior of that particular problem, or else they will not be equated in a ratio and proportion. There's a reason behind why you do that. The molecular formula will be over to like this. It's not a magic also. And the students must understand in the first place. So I have empirical formula It's their right because they are paying you money for their salary every month. Something like that, okay? So empirical formula. Okay? So what is your molecular weight in your empirical formula? I have now C2H6O. Then get the molecular formula in terms of the empirical formula. So get it. Okay. 2 times 12 sa carbon plus 6 times 1.008 sa hydrogen plus 16 sa oxygen. I add all the atomic masses with its corresponding individual subscripts. Then nasa ubos. Okay? Like that. Okay. 2 times 12 is very clear, 24. 6 times 1.008 I cannot determine because it's with point something. Okay? So I must do this by calculator. Okay, 6 times 1.008. Mga palangga, are you still listening? Any questions so far? Okay. Plus 24 plus 16. We have 46.048, the same unit gram per mole. So 46.048 gram per mole. Why? Because this is already a compound, not an individual element. That's why it's not gram atom. You get the point? Okay. So, gram per mole. I have here. So, chemical formula is equal to the molar mass, which is 204 gram per mole in terms of chemical formula. And then, empirical formula is equal to its molecular weight in terms of the empirical formula, which is 46.048. I do the ratio and proportion because we have the same unit grams per mole. Okay, and at the same time, we are only one in this problem. Okay, I will say, chemical formula. Oh, ganon. Chemical formula, so I will say 138.24 is to chemical formula. Okay, and then 46.048 is to the empirical formula. Okay? Like, and 138 is the chemical formula. So I have now the ratio between the chemical formula and the empirical formula. So if you divide that two, that will be your ratio. Okay? So divide it two so that you can determine now the chemical formula. Okay? You get the point? You get the point, mga pala? So, if we are very strict also, if you consider math here, it's also okay, but it's quite complicated to understand for the students, but anyhow, we can still justify. So, I will just do this again. Okay. Ratio and proportion. Chemical formula is to 138.204. Okay. Then I will say empirical formula is equal to 46.048. The ratio and proportion. I will say chemical formula. Chemical formula is unknown, right? You will say, but in the problem is carbon, hydrogen, and oxygen. So you will put carbon X, hydrogen Y, oxygen Z. I put 3 letters in each element because these are the unknowns, subscripts that will turn into an atom later on. Okay, when you multiply that with a mole. Okay, so unknown X, unknown Y, and unknown Z, unknown subscript. This is your empirical formula. Okay. Chemical formula over 138. Okay, mo man niyang chemical formula, mula mas, di ba? Oh, ganun. And I have to say, empirical formula. Oh, saan sa ito? Empirical formula. C2H6O. Is what it is? C2H6O. And then over 46. Ganon. 46.048. Now, crisscross mathematics. Like this. What will be happening now? So, it's gonna be like this. Okay. Like this. It's gonna be 46.048 coefficient of CXYOZ. Right? Crisscross in math. And it will become also C2H6O multiplied by 138.204. We cannot simplify further, mga palangga, because this is not all numbers. Okay, this is a variable. Okay, since you are looking now for CXHYOZ, solve for that. In mathematics, you need to divide to a certain thing so that it will be cancelled. So here, divided by 46.048 so that it will now become CXHYOZ, in which that is we are trying to find out. Oh, cancel. Then divide also the other side with the same thing because that's the rule of math. If you divide a certain number in the other thing, divide also the other in the same number. So I will also divide this by 46.048. Our ratio. Okay, it's very clear really. So CXHYOZ is equals to C2H6O times the fraction or the ratio of 138.204 46.048 divided to 1. Okay. Guys, sorry guys, this is the thing that I confused when I was in college. Namumutra ko. I need to understand really. Okay. Okay, 138. Though I understand already, but not really that high. I think 70%, 80%, not really full. But I'm already graduated and become already legit licensed chemical engineer. Then I know already, it's gonna be like that. So it's good to be back in school para ma-perfect. Charot. 138.204 divided by 46.048. So it's now become 3. 3. Klaro kaayo. 3. Now, this 3 will be multiplied by the subscript of the empirical formula. Like this. It will become now C3 3 times 6 3 times 2 is 6, right? Okay, 6 times 3, 18, and O is 3. So your chemical formula is C6H18O3. Because in the fraction here, the ratio is 3. Multiply this with the empirical formula subscript, it will become like this. So you have now the X equal to 6, Y is equals to 8, and Z is equals to 3. Okay, ganon. So your chemical formula is C6H18O3. Muna yung answer. Okay, C6H18O3 is the compound. Now, take a look what compound is this in the Chemical Engineer's Handbook, in the books of chemistry, in Google search this, in your, if you have data, and then search. If have equivalent like this, and that is the name of the compound. 6 atoms of carbon, 18 atoms of hydrogen, and 3 atoms of oxygen. Because sometimes also, after getting the chemical formula, we can obtain also a non-existent compound. Non-existent meaning, you have the chemical formula, but still you don't know what is that. Meaning to say, that's only for the purpose of examination, discussion, so that you learn how to do it. Okay? And there are also situations that the actual chemical formula you obtain have also the same in the books, in the chemistry books, in the Chemical Engineer's Handbook, or whatever sources, because that's really existent. It exists already through experimental evidences. Like that. That's gonna be sucrose. Like, for example, if you will reach like this carbon 12 or H22O11, which is the chemical formula of table sugar, or sucrose, the white sugar, refined sugar we buy in the market. So there are 12 atoms of carbon, 22 atoms of hydrogen, 11 atoms. If we obtain that chemical formula in our problem solving, then you will say, sucrose is the unknown compound in a particular problem. Okay, we don't know, we don't refer the book already because I memorized already the exact chemical formula of sucrose or sugar. Okay? This involves with other compound, but we cannot memorize everything, right? So if we come up with a chemical formula like this, then refer to the books, refer to the references or whatever, double search that, Google search that, or it's up to you. But if the problem stops only in the chemical formula, you don't have to do that. Only for the purpose of discussion, I teach you. Okay? Like that. Okay? So if we modify this problem also like this, so what is the name of the compound in letter D? A. What is the molecular formula? B. What is the empirical formula? C. And what is the compound? What? None. So that's the time you will refer to different references to troubleshoot what is the compound all about. If it present really. Now, if nothing there but close, very close, again, your computation, then judge that as it is, because it's very close, especially if the question is multiple choice. Okay, there's a lot of compound mentioned, A, B, C, D, E, like that. Okay, go to the nearest atoms reflected in the chemical and answer them in the way. But if it is very far, okay, and there's letter E in the choice, none of the above, you choose none of the above in your answer, in the question. You get the point? You will feel that if it is too far and if it's too close. What I mean of too near, point something, point something. But too far is already the figure. Like for example, C3 dapat na C2 dito. Layo na siya. Okay, but if C2.3 and then 2, then it could be acceptable because there's no such atoms that will have point something too much. Okay, for example, 2.3. Oh, you did 2.3. So consider that as 2. Right? Ganda na siya chuba-chucho. You got the point. Okay, and then if it is 2.9 or 3, consider that as 3. Ganda na siya chuba-chucho. And review the rule also of how to round off in your algebra. Round off numbers to the nearest 10, nearest 100, because there's also a rule for that. Okay, in math. You get the point? Rounding off digits. Like that. You can still remember that. Elementary, right? Grade school level. Rounding off numbers. There's a rule. After add, you cannot do the rounding off. If it is even, it's okay to rounding off. Like that. There's a rule for that specifically. Okay? But we don't have to be particular for that. As long as we already get the desired answer. Like that. Okay? Any questions so far mga palangga? Please forgive me that my writings are very, very confusing because so much erasures. And there's a limited space. Canon. Okay, thank you so much for watching this topic, molecular formula and empirical formula. Okay? Like that. Okay, any question? You can subscribe now, my YT channel if you want. And then thank you for supporting my YT channel, mga palangga, because, you know, my revenues are always escalating. Thank you so much. You can click the notification bell for some years updates of MSC. If I will stop vlogging, then problem. This is only my only hope. Okay? Because I don't have trending views. Okay? Like that. Okay, so I have to do so many vlogging so that I can compensate to the revenues, you know, rising of my analytics. We call that as an analytics. If you are a YouTuber, you have an account, we call that, and your account is monetized already. You have to be particular on your analytics. If it's going down, it's going up, dili ala to. And you have to project also the viewers. I have a lot of viewers in Saudi Arabia. My gosh, particularly, maybe that's only me. I'm watching. Okay, and then in Philippines also. Okay, like that. Because you can see there who are the, not exactly the people who are they, but the age bracket, 10 to 18, 20 to 30. The ages of the people that watch your videos will be reflected there. So you can troubleshoot image. And the female also, female, female. I found so many men watching my videos. Okay, probably that is in Saudi Arabia. I think so. Okay, and there's not too much younger. It's in the range of 30 to pataas. So mga adult, mga guangers. Those who watch my videos are mga tiguang, sure. Instead of projecting this to senior high school students, and I wonder why the people watching are mature. Really, you can see that in your graph analytics in your YouTube if you are monetized. Okay? Like that. And you enjoy a lot. Oh my gosh. Thank you so much for watching mga supporters. Bye-bye. God bless everybody. Happy lang ang life. Bibi and Sarah. Thank you so much. Uy, kakaloka. O, diba?